Swiss Perovskite startup sets up indoor solar cell manufacturing. Indoor solar cell developer, Perovskite Solar, is setting up a factory in Switzerland that may reportedly print 1 million of its custom-designed perovskite devices annually. It targets the market for self-powering consumer electronics and Internet of Things devices, such as fire alarms, fitness trackers, and sensors. Perovskite Solar, a Swiss developer of indoor solar cells, is setting up a factory in Aubonne, Switzerland to produce 1 million printed perovskite devices annually. It is a sheet-to-sheet production line based on commercially available equipment with minor customization. It includes a new in-house built tool to simply print the encapsulation material, Anand Verma, Perovskite Solar's CEO, told PV Magazine. The full cell stack with contacts is printed in-house on glass substrates. Perovskite is a spin-off of the Swiss Federal Laboratories for Materials Science and Technology, EMPA. It was founded to develop the market for customized perovskite solar devices as battery replacements. A recent design and win was a bracelet-style health tracker developed by France-based Barracuda, which won an innovation award last year at the 2023 CES Consumer Electronics Show in Las Vegas, Nevada. In 2023, Perovskite had 15 original equipment manufacturers, OEM, in the process of evaluating, testing or producing products. 2 out of 15 were already using another indoor PV technology, either amorphous silicon or organic PV. The rest were using conventional batteries. That confirms to us that the application is clearly battery replacement, said Verma. Optimized for indoor light condition, Perovskite Solar's latest generation of cells have an open circuit voltage of 0.9 V and a power output of 80 microwatts per square centimeter to 85 microwatts per square centimeter under indoor lighting at 1000 lux. We are aiming to increase it to 100 microwatts per square centimeter to 120 microwatts per square centimeter in a development project with EMPA, said Verma. As for stability, Verma noted efficiency of 80% is maintained after 5,000 hours of full sun exposure. The devices also reportedly retains 90% of its original efficiency after 1,000 hours. Indeed, we have passed accelerated benchmarks. The typical perovskite degradation rates are avoided by using additives, said Verma, adding that the devices comply with restriction of hazardous substances in electrical and electronic equipment, RoHS, standards.